plus 2 times the quantity now of 4 to the n minus 1, plus 4 to the n minus 2, plus 4 to the n minus 3, plus da-da-da, plus 4 squared, plus 4, plus 1. Okay. Which, correct me if I'm wrong, guys, doesn't that look exactly like this, except instead of the nth power, doesn't it start at the n minus 1? So wouldn't we just replace this n over here with n minus 1, since that starts at the n minus 1 power? Okay? So, what we can do is we can now rewrite this as 4n times 3. This guy's an oddball term, okay? No matter what, it just doesn't jive with the rest of them because it has a coefficient of 3 as opposed to 2. But all the other ones have coefficients of 2. So we could say plus 2 times the quantity of 4, since this is n minus 1, instead of n plus 1, we're going to write n minus 1 plus 1. Okay. So all I did was I just plugged in n minus 1 right here. Because this starts at n minus 1, I just substitute minus 1 over 3. Okay. Now we're going to get to the initial conditions and all that stuff in a second. Okay. Does that make sense, guys, as to why we did that? Okay, this form is the closed form of this series right here. Okay, we could prove that by induction. In fact, I think that we did prove that by induction on one of your homework problems. Okay. All right. So now we're just going to do some algebra. We're going to tidy this up, and then we can do the initial conditions. Okay. So I'm going to go ahead and make that 4 to the n minus 1 over 3. So now we get that this is going to be equal to 4 to the n times 3 plus, now we have 2 quantity 4 to the n minus 1 over 3. Okay. We can still clean this up even more. Okay? Because couldn't I distribute the 2 and separate this term into 2 separate terms just by breaking apart the fractions since we're dividing by a monomial? So we could write this as 4 to the n times 3 plus 2/3 times 4 to the n minus 2/3. So let me make sure everyone's okay with that. Okay. But does everybody see what I did there? Basically, I distributed 2 in the numerator, and then I split it up into 2 terms. Okay, so this term, or this fraction, just became those 2 terms.
Take 4 to the power n common.
Yeah, guys, there's common terms there, right? Don't we have 3 4 to the n's and 2/3 4 to the n's? So we could just play collect like terms. If I combine those, 3 plus 2/3, I believe, is going to be 11/3 times 4 to the n minus 2/3. Okay. So all I did there, guys, I just took 9/3 plus 2/3 to get 11/3. Okay? And that's probably the most simplistic, non-recursive form that I could get. I could factor out a 1/3 if I wanted to, but this is what I'm going to stick with. Okay? Now, unfortunately, this doesn't mean anything unless we have the correct initial value for this. Okay? So, obviously, n has to be an integer. But what value should n start with if we want to make sure that we get the correct initial condition? And just to remind you guys, okay, let's go back to the original problem. D sub 0 is equal to 3. Okay, so whatever we plug in, okay, we need to get to a 3 with this. Okay, so I think 0 might be it, right, guys?
4 to the power 0 is 1, yeah. 11 third minus 2/3 is 1.
Yeah. So all we're going to do is we're going to start at 0. Okay? And the reason we start at 0 is because if we substitute 0 back in here, okay, here's how we check this.
Yep.
11/3 times 4 to the 0 minus 2/3. And that just becomes 11/3 minus 2/3, which is going to be 3. And that's good, because remember we said that the initial condition, d sub 0, should be equal to 3. All right, so,
If you do all that, you get to your closed form, but when you plug the initial condition, the 0 in, it doesn't work, then
change the
but
index.
1 does.
Yes,
You just
start
say
it.
n equals 1.
Correct.
or
What you're
greater
doing
than
is you're
equal
just
to
looking for the initial value of the iterator, basically what you're trying to get to.
1. But they're always gonna, the n is greater than or equal to is always gonna be either the same as the initial condition or only 1 away from it.
One,
depending
right,
on
it
which way
should
you're
never
going.
be any more than 1 away from it. I mean, you could if you really wanted to, but that would be
But then
extremely.
you're skipping what one of them would, you're skipping a condition.
Yeah, well, basically, yeah, okay, or you just tried really, really hard to do a change of base, or change of index, if you would, which you don't wanna do with this, okay? Alright, so guys, now, on a scale of 1 to 10, when it comes to taking recursion and putting it into, something that's easily indexable, this is like a 1.5 out of 2, or out of 10, I guess, so out of 2, that'd be nice. So this guy's a really easy example of how to take something that's recursive and write it into something that you just do explicitly, okay? So if you want to make some real money, okay, in your life, and I'm talking like somewhere in like the $500,000 range, start doing like your 4s and 5s out of 10s, okay? But those are really, really tough. Those are like
Which
maybe,
one?
what's that?
Which
Like
one?
about a 5 or 10, a 5 out of 10.
Uh-huh.
That's where you really, really, really make some money doing that stuff. So, but this stuff's like baby stuff. This is stuff that you can do in like maybe an hour. The other ones probably take like 4 or 5 weeks to do or something like that. So yeah. So have fun with that if you want to. All right. So anyway, I'm going to show you guys one more example of this, very similar, so that way you guys can see the process. And again, with these types, we're going to be using these special forms of the closed summations. Okay. So we have our last sequence up here. We have e sub k, which I had before, but I erased unfortunately. So e sub k is going to be equal to 5 e sub k's minus 1, okay, minus 3. E sub naught is equal to 2, and we're saying that k should be bigger than or equal to 1. All right. This problem is actually very similar to the previous, okay? All we have to do is just make sure that we have the correct sort of iterations going with this, okay? And that we don't simplify too far, if you would, okay? So, we already know what e sub 0 is, or e sub naught is 2. E sub 1 should be very, very easy for us to compute. We just substitute 2 back in for e sub k minus 1. So this becomes 5 times 2 minus 3. Okay? We could write that as 7. I highly doubt that after maybe the 3rd or 4th iteration, any of us would see a pattern. Okay? E sub 2. 5 times the previous instance, so 5 quantity. 5 times 2 minus 3 minus another 3. So, everybody okay with how we did that, guys? All we did was we took 5 times 2 minus 3, plugged it back into the previous instance. Okay? Again, we could compute that. We could say 5 times 7 is going to be 35. 35 minus 3 is 32. That doesn't help us. Okay? I always suggest to people keep it in the exponential form. Okay, so let's write this as 5 squared times 2 minus 5 times 3 minus 3. Okay? And I believe that form is going to be much more useful to what we have with the formulas. Okay? Let's go ahead and maybe write the next 2 or 3 iterations, because I bet you after 2 or 3 of these, you guys are all going to see the pattern. Okay? E sub 3. That's 5 times the previous instance, 5 squared times 2, minus 5 times 3 minus 3, okay, minus another 3. And then all we're going to do is we're just going to distribute the 5 to all 3 of those terms. Okay, so this is going to end up being 5 cubed times 2 minus 5 squared times 3 minus 5 times 3 minus 3. Okay. So I'll let you guys copy that down while I erase the other board, just so we could do like maybe 1 or 2 more of these instances. So I'm betting there's some of you guys that can probably guess what e sub 4 might be. Okay. So let's just write out e sub 4, let's write out e sub 5, just from what we think it's going to be. And then maybe what we can do is come up with some sort of closed form for this. So does somebody want to take a guess and tell me what they think or know e sub 4 to be? Go ahead.
5 to the power 4 times 2
Okay.
minus 5 cubed times 3
Okay.
minus 5 square times 2
Times 3.
3, 3.
Yep, times 3. That's okay.
3 minus 5 times 3 minus 3.
Yep, good. And again, that's after you do your substitution and your simplification, okay? I'm assuming that you guys can start seeing the pattern here, okay? For the second iteration, you had a 5 squared times 2, and then 5 times 3. For the third iteration, you had 5 to the third. So basically, anything with a coefficient of 3 starts with 1 less than the index. Okay? I'm betting that if you guys were to go through and do e sub 5, I bet you most of you guys could write out e sub 5. Okay? E sub 5 is 5 to the 5th times 2, 5 to the 4th times 3, 5 to the 3rd times 3, minus 5 squared times 3, minus 5 times 3, minus 3. Okay. So my suggestion, guys, would be to write out maybe the first 5 iterations, because with 5, it's not too many that it's painful, but it's not too few that you don't see the pattern. Okay? There's always that balance, like how much is enough. I always say like maybe the 5th or 6th iteration is perfectly fine. Okay. So everyone good with these, guys? Any questions so far about how we actually wrote out the iterations? Okay. So now we actually have to get to the closed form. Okay, that's a tough thing to do. Right? So let's now try to guess this for the e sub nth term. Okay, in other words, instead of guessing out to maybe the 77th term, let's think what might happen the 77th time. Okay? So does anyone want to take a guess and tell me what they think or what they know e sub n might look like?
5 to the power n times 2.
Okay, so 5 to the n times 2, good.
Then you take minus, take the 3 common, or
We'll do that next, that's fine.
Okay.
But you're okay, Art, go ahead,
okay,
keep going.
5 to the power n minus 1 times 3.
Yes, sir.
Then n minus 2 times 3, n minus dot 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 up to
Right.
3.
Yeah. So basically, the coefficient 2 starts with 5 to the nth, and then the third, or the coefficients of 3, okay, are going to start with the 5 to the n minus 1. Instead of plus, I'm going to use minus, because I had to put a plus there, but we can clearly see that all the terms are negative rather than positive. Okay? So it's going to be minus 5 squared times 3, minus 5 times 3 minus 3. Okay. All right, and then guys, just like in the previous problem, we factored something out. So what should we factor out, and where should we factor it out?
3,
Not just 3, but negative 3,
negative 3.
right? Because remember, we have special forms of summations, okay? Not negative versions of those, okay? So let's factor out a negative 3, but let's start right here. Obviously, this first term doesn't have a 3 that we can factor out, okay? So e sub n is 5 to the n times 2. And then we have our minus 3, which we're going to factor out. And that's going to be a 5 to the n minus 1 plus 5 to the n minus 2 plus, plus 5 squared plus 5 plus 1.
It reminds me of Calc 2.
Yeah, it really does look like some of the series that you guys have seen in calculus too. Okay. All right, guys, at this point, it's almost obvious that what we have in parentheses is very, very, very close to what we have as the very last entry on that sheet with the closed form of summation. Except, once again, we don't start at the nth power, we start at the n minus 1 power. Okay, so once again, when we substitute, because we have an n minus 1, we're going to rewrite this as 5 to the n times 2 minus 3. Now quantity, instead of 5n n plus 1, we're going to have 5 to the n minus 1 plus 1 minus 1 over 4. Okay, now we're going to worry about the initial condition in a moment. Okay? But I want to make sure that you guys are okay with that. Okay, so everybody see how we're substituting back in? Okay, if it was n minus 2, you just substitute n minus 2 back in there. Okay, it just depends on where the index starts and stops with this. Okay, now we're going to clean this up. Okay, so let's go ahead and do a little bit of algebra to clean it up. Okay, if we do so, we're going to distribute the negative 3, and we're also going to split it up into 2 terms. Okay, and when I say yeah, I mean this parenthesis here. So this is now going to become 5 to the n times 2 minus 3/4 5 to the n, and then plus 3/4. Notice we have a negative and a negative. 3 times negative 1 becomes the 3/4. So, is that okay with everybody, guys? Any questions about that, Doug?
Why don't you split that up in the fraction that in
Oh,
the previous step?
right here or up here?
No,